Good morning to one and all. Myself Dr. Ramgopal, Associate Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. I welcome you all to today's session on testing of hypothesis concerning one mean large samples. Let us recall the previous session. In the last session, we have discussed the steps involved in the procedure of testing of hypothesis and different types of tests. The steps involved in the procedure of testing of hypothesis are setting the null hypothesis, then setting the alternative hypothesis, then level of significance, critical region, test statistic, and finally the decision. And also we discussed different types of tests such as testing of hypothesis concerning one mean, two means, one proportion, two proportions, testing of hypothesis concerning variances, goodness of fit, etc. Now the overview of today's presentation. First I will define parameter, statistic, large sample and small sample. Then the notation that we use in testing of hypothesis and testing of hypothesis concerning means, and in particular concerning one mean and large samples. And also we discuss some problems in today's session. Now a parameter is any statistical measurement calculated using the population. That means if we calculate the mean of a population, that is called a parameter. Similarly, variance of a population, that is also called a parameter. So any statistical measurement calculated using the population, that is called parameter. Now statistics. Any statistical measurement calculated using the sample data is called statistic. For example, mean of a sample, variance of a sample, these are called statistic. So if we calculate any statistical measurement using the population, that is called parameter, and using the sample data, that is called statistic. Next, large sample. A sample is said to be large if the size of the sample n is greater than or equal to 30. So including 30, the sample is said to be large sample. Size of the sample means the number of elements considered in the sample. So if there are greater than or equal to 30 elements in a sample, then it is said to be a large sample. Next, small sample. A sample is said to be small if the size of the sample n is less than 30. So up to 29, the sample is said to be small sample. Now coming to the notation that we use in testing of hypothesis. Here the measurement, the statistical measurement that we calculate, for example size, the mean, variance, standard deviation, proportion. Now for population, if we calculate any statistical measurement, that is called parameter, just now we defined, and for a sample, that is called statistic. Here the size of the population is denoted by n and the size of the sample is denoted by small n. Similarly, mean of the population is mu and mean of the sample is x bar, and variance of the population is denoted by sigma square and variance of the sample is denoted by s square. Similarly, the standard deviation, and we know the standard deviation is the positive square root of variance. So the standard deviation of population is denoted by sigma and standard deviation of sample is denoted by s. And proportion of a population is small p and proportion of a population is capital P. This notation we are going to use in the testing of hypothesis. And the next, the test of hypothesis concerning means. In test of hypothesis concerning means, there are two types. The sample can be large or small. Now today we are going to discuss only about the large samples. And again in the large samples, there are two types, one mean problems and two mean problems. If we are discussing about a single mean, that means about a single population, that comes under testing of hypothesis concerning large samples, one mean problems. If we are discussing about two populations, that means two population means, then that comes under testing of hypothesis concerning two means for large samples. Now, the testing of hypothesis concerning one mean large samples. In one mean large samples, we use the Z distribution, which is called the Z test, and the procedure is as follows. And already we have discussed the steps involved in the testing of hypothesis, like null hypothesis, alternative hypothesis, level of significance, critical region, test statistic or the calculation part, and finally the decision. In testing of hypothesis concerning one mean for large samples, since there is only one mean, there is only one population, so the mean of the population mu will be given as some constant mu naught. So, the null hypothesis should be always in the form of equal to. Here we consider the null hypothesis as mu equal to mu naught, and as we know that alternative hypothesis is the hypothesis other than null hypothesis. So, it will be in the form of either less than or greater than or not equal to. Since we have considered the null hypothesis as mu equal to mu naught, here we test this null hypothesis against the alternative hypothesis either mu less than mu naught or mu greater than mu naught or mu not equal to mu naught. Next, level of significance. The level of significance is denoted by alpha, and the most general values that we consider for alpha are 5% or 1% level of significance. Then the critical region. The critical region is the region in which we reject the null hypothesis H naught. So, here in fourth step we write the conditions when we reject the null hypothesis. In one mean large samples, these are the conditions to reject the null hypothesis. Again, the critical region depends on this alternative hypothesis. As we have discussed in the last session, depending on the alternative hypothesis, the tests are divided into two types, one tail test and two tail tests. If the alternative hypothesis is not equal to type, then the test is called two tail test. If the alternative hypothesis is of less than or greater than type, then the test is called one tail test. And again, if the alternative hypothesis is of less than type, then the test is called left one tail test. If the alternative hypothesis is of greater than type, then the test is called right one tail test. So, here the critical region depends on the alternative hypothesis. Now, reject H naught if Z calculated is minus Z alpha for alternative hypothesis less than type problems. So, if we consider the alternative hypothesis is of less than type, then we reject the null hypothesis if the calculated value is less than the corresponding negative tabular value. Similarly, if the alternative hypothesis is of greater than type, then reject H naught if Z calculated is greater than Z alpha. That means if calculated value is greater than the tabular value, simply reject. So, if the alternative hypothesis is of greater than type. Next, if the alternative hypothesis is of not equal to type, then reject H naught if Z calculated is less than minus Z alpha by 2 or Z calculated is greater than Z alpha by 2. That means, in not equal to type, the test is called two tail test, and the critical region of area alpha by 2 lies on left side and the critical region of area alpha by 2 lies on right side tail. So, that is why we compare the tabular value and calculated value according to this sign of the calculated value. If our calculated value is negative, compare with this negative condition. If it is positive, compare with this positive condition. Now, coming to the step 5, the test statistic. Here, the data follows a particular theoretical probability distribution. In testing of hypothesis concerning means, we use Z distribution or Z test for large samples. So, here the test statistic is given by Z calculated is equal to x bar minus mu by sigma by root n. Here, just now we discussed the notation that we use in testing of hypothesis. Mu is the mean of the population, x bar mean of the sample, sigma mean standard deviation of population, and n the size of the sample, So, here in testing of hypothesis, one mean for large samples we use this test statistic. Z calculated is x bar minus mu by sigma by root n. Now, comparing this calculated value and the tabular value, we take the final decision whether to accept the null hypothesis or to reject the null hypothesis. Now, let us use this table as a reference table to find the tabular values. For 1% level of significance, 5%, 10%, but the most general values are 1% and 5%. In two-tailed tests, that means not equal to type problems, plus or minus z alpha by 2 is plus or minus 2.58 for 1%, plus or minus 1.96 for 5%. Similarly, right one-tailed test greater than type problem, these are the values of z corresponding to 1% and 5% level of significance, and here left one-tailed test less than type. Let us discuss a problem on testing of hypothesis concerning one mean for large samples. Now, let us consider this problem. A machine runs on an average of 125 hours per year. So, the given data is a machine runs on an average of 125 hours per year. A random sample of 49 machines has an average use of 126.9 hours with standard deviation of 8.4 hours. Does this suggest to believe that machines are used on the average more than 125 hours annually at 5% level of significance? That is the question. So, again I repeat, a machine runs on an average of 125 hours per year. A random sample of 49 machines has an average use of 126.9 hours with standard deviation of 8.4 hours. Then, does this suggest to believe that machines are used on the average more than 125 hours annually at 5% level of significance? Now, coming to the solution part. So, first write the given data, what is given in the problem. A machine runs on an average of 125 hours, average means the mean. So, this information is regarding the entire population. So, given population mean mu is 125 hours per year and a random sample of 49 machines. So, sample size n is given 49 and then this sample has an average use of 126.9 hours. So, again the mean of the sample is given as x bar is 126.9 and with standard deviation of 8.4 hours. So, S is given as 8.4 hours. Now, does this suggest to believe that machines are used on the average more than 125 hours annually at 5% level of significance? So, alpha is given as 0.05. So, we need to test whether the machines are using more than 125 hours annually. So, to test the null hypothesis, as we know, the null hypothesis must be in the form of equal to. So, the given statement which is to be tested is called the null hypothesis. So, here the statement given is the machine runs on an average of 125 hours. So, this mu equal to 125 is the null hypothesis. Now, the test is as follows. The first step is null hypothesis H naught. The null hypothesis in this problem is mu equal to. So, the null hypothesis must be in the form of equal to. So, mu equal to 125 hours. Next, alternative hypothesis. Alternative hypothesis is any hypothesis other than null hypothesis. So, we have to consider the alternative hypothesis in any of the three forms less than type, greater than type or not equal to type. Now, this alternative hypothesis will be considered basing on the given data itself. In the problem, particularly a hint will be given. We need to check whether the machine runs on an average more than 125 hours or not. So, that means we need to test this null hypothesis against the alternative hypothesis mu greater than 125 hours. So, the null hypothesis is mu equal to 125 hours and alternative hypothesis is mu greater than 125 hours. Now, the level of significance, it is given alpha as 5% means 0.05, alpha equal to 0.05. Now, critical region, this is greater than type problem. So, reject H naught if the calculated value of Z is greater than Z alpha. So, here for alpha equal to 5% level of significance, we can see the reference table to find this Z alpha. So, Z alpha is Z 0.05 is 1.645. So, this is the tabular value of Z. Now, coming to the calculation part, here the test statistic is given by Z calculated x bar minus mu by sigma by root n. So, this gives the calculated value of Z. Now, we can substitute the given values. X bar is given in the problem 126.9 and S is 8.4, 126.9 and S is 8.4, 126.9 minus 125 by 8.4 hours, 8.4 by a random sample of 49 machines, n equal to 49. Now, we need to calculate this value and finally, we compare this value with the tabular value and we take the final decision. Okay. So, after substituting these values, this will be 1.58. So, the calculated value of Z is 1.58. Now, the last step, decision, and here since our calculated value is 1.58 and tabular value is 1.645 and is less than, that means the Z calculated is less than Z alpha. Here if Z calculated is greater than Z alpha, we have to reject, but here Z calculated is less than Z alpha, that implies accept the null hypothesis H naught, accept the null hypothesis that the machine runs on an average 125 hours. So, this is the procedure of testing of hypothesis concerning one mean for large samples. Similarly, let us discuss one more problem. In a random sample of 60 workers, the average time taken by them to get to work is 33.8 minutes. So, it is given n equal to 60 and this 33.8 is the data related to this 60, that means the sample. So, the sample mean is 33.8 with a standard deviation of 61 minutes, S is 61. Test whether the mean of the population is 32.6 minutes or not. So, mu is 32.6 or not at alpha equal to 5% level of significance. So, this is the data given. And here it is clearly mentioned test whether the mean of the population is 32 minutes or not. That means we can consider the alternative hypothesis in not equal to form. Now, coming to the solution, the procedure of test of hypothesis follows. First, the null hypothesis is the mean. Here the mean of the population is 32.6. So, mu equal to 32.6. And the alternative hypothesis is not equal to type, 32 mu not equal to 32.6 and level of significance 5%, 5% means 0.05 and critical region it is not equal to type. So, reject H naught if Z calculated is greater than Z alpha by 2 or Z calculated is less than minus Z alpha by 2. So, in 5% level of significance, plus or minus Z alpha by 2 is plus or minus 1.9, plus or minus 1.96. So, at 5% level of significance, alpha is given as 0.05. Now, coming to calculation part, the Z calculated is given by x bar minus mu by sigma by root n. So, x bar is the mean of the sample mean of the sample is given 33.8. 33.8 minus 32.6 by sigma is also, in place of sigma S is given. So, we can replace sigma by S, and by calculating this value we will get 1.5238. 1.5238. So, here the tabular value is plus or minus 1.96, and here the calculated value is positive. So, we compare with the positive tabular value, and since our calculated value is less than 1.96, the tabular value, if calculated value is less than minus Z alpha by 2, we reject it, or Z calculated is greater than Z alpha by 2, we can reject the null hypothesis. But here what we got, Z calculated is less than Z alpha by 2. Therefore, accept H naught, that mean work time is 32.6. Similarly, let us discuss one more problem. Mice with an average lifespan of 32 months will live up to 40 months when fed by a certain nutritious food. If 64 mice fed on this diet have an average lifespan of 38 months and standard deviation of 5.8 months, is there any reason to believe that average lifespan is less than 40 months? So, here the given data is mice with an average lifespan of 32 months will live up to 40 months. So, it is given mu equal to 40. If 64 mice, so n equal to 64, fed on the same diet, average lifespan is 38 months with standard deviation is 5.8 months. Now, is there any reason to believe that the average lifespan is less than 40 months? So, here this less than is given, that means we consider the alternative hypothesis as less than type. And this do not concentrate on this 32 months, this is the general information given, and the claim is they live up to 40 months. So, the null hypothesis mu equal to 40, alternative hypothesis less than 40, level of significance 1%, and critical region reject H naught if Z calculated is less than Z alpha. For 1% level of significance, this less than minus Z alpha. So, minus Z alpha for 1% level of significance, this value is minus 2.33. Coming to the calculation part, the Z calculated is given by x bar minus mu by sigma by root n. So, 38 minus 40 divided by the sigma. Go back to the problem. Here 64 mice, n is 64, x bar is 38, 5.8. So, 5.8 by root 64, and this is equal to minus 2.76. And the final decision, now we can compare these two values. Since minus 2.76, now this 2.76 is greater than 2.33 if it is positive value. So, that means the negative value means this is less than. So, Z calculated is less than minus Z alpha by 2. Therefore, reject H naught. So, our final decision is to reject the null hypothesis. That means the average lifespan is not 40. If we are rejecting the null hypothesis, that implies we have to accept the alternative hypothesis that even after giving that nutritious food, the average lifespan is less than 40 months itself. Now, summary of the present session. In today's session, we have discussed definitions of parameters, statistics, large samples and small samples. The notation that we use in testing of hypothesis is also discussed. Now, and the test of hypothesis concerning means, particularly one mean for large samples, and we have discussed some problems also. In the next session, we will discuss about the testing of hypothesis concerning two means for large samples. Thank you very much.